Okay, so obviously we're going to have some secrets to keep here, right? And what I'm going to do right now is try to show you how much energy there is in a gummy bear. And I know that I met Evelyn about 2 years ago, and she's been looking forward to this since then, as have I. And gummy bears, the main ingredient, not quite the only ingredient, but basically the only one that matters, is glucose, okay, sugar. We've been talking about that a lot in the last 2 years. I just want to show you the image of a glucose molecule. These are all simple sugars, but glucose is over here on the right, and you can see that wild card of hydrogen is all around the outside of the jackknife of carbon. Okay, so you can also see it's a long, skinny shape and pretty unstable. And if you imagine that there's oxygen all around it, and those oxygen atoms are bullies, and they want to react with the hydrogen and with the carbon both. And they're going to do that. Okay, but why aren't they? Why aren't they doing it now? And when you eat this gummy bear, you provide it with a little jump start of energy in your cells and some oxygen, and it reacts with your enzymes. We don't have that chemical here, but what we're going to do is we're going to add, what we're going to do is we're going to create a situation where there's a lot of oxygen that's moving fast, and it's going to be slamming into this gummy bear all over the place, and it's going to have a chemical reaction then. And so the source of the oxygen is going to be this chemical here. I wasn't sure which one I was going to be able to get, sodium chlorate or potassium chlorate, and I got sodium chlorate. And you can see the diagram here. There are all these oxygens around the outside stuck to this one chlorine. And it's not a stable compound, right? If you really give it a good shake, right? If you really shake it, what's going to come flying off? The oxygens. So what we've got here is a tube with some sodium chlorate in it. And we're going to give it a good shake. And it's going to rattle the oxygen free. Except I'm not young or strong enough to do that anymore. So what we're going to do is we're going to add thermal energy to do that. So I'm going to raise the temperature of this so that the oxygen comes, flying, busted off, and then I'm going to, when it gets full of oxygen and it's high temperature, they're moving fast, I'm going to stick a gummy bear in there, and hopefully we'll see how much energy there is in a gummy bear. So don't forget to keep our little secret. I'm going to turn the lights out so we can see it a little better. I'm going to close the door for privacy, and I'm going to turn the fan on. And, okay, so here we go. I'll wait to turn it. So I'm raising the temperature of this, moving the torch around, hoping not to crack the test tube. Yeah, I've got it a little bit molten there. I'm going to come over here and turn the lights off, not on. Okay. It makes it a little harder to see the sodium chloride in here, but I hope that fan doing a good job. Okay, so these are dragon-powered gummy bears. I forgot to say that. And right now, I think okay, so what just happened? We gave the gummy bear, we gave the glucose a bunch of oxygen that was moving fast, and it released a lot of energy. And that's just to show you the potential of the electromagnetic force and chemical reactions causing things to move. Thanks.